Pandas is extensively used for data cleaning, exploring, and manipulation in Python. It allows for easy importing and exporting of data from multiple sources like Excel, CSV, or HTML into Python data frames. In this video, I am going to give a walkthrough on the use of pandas in Python to analyze a salaries dataset pulled from Kaggle. The dataset has been linked in the description box in case you want to code along to practice your Python skills. You can download this dataset and move it in the same folder as the Jupyter notebook you would be using. So let's get started. First up, I am going to import my libraries, that is pandas and numpy. Next, I am going to read the salaries dataset, which is stored as a CSV file, as I said earlier, in the same location in which the Jupyter notebook is stored. So you can use pd.read method, and as you start typing read, you can press tab and it will give you all the options for different kind of data sets that you want to upload. Here we will select pd.read underscore csv, and then as you start typing, press tab again, and the Python will automatically give you the options available uh, to be uploaded, and you can select your data file. Next, we have to check the head of the data frame. For this, we will use the head method, and you can input the number of rows which you want to select. The default is 5 rows. If you want more or less number of rows, you could input the integer like this. So as we see in this data frame, we have these columns. We have an ID column, employee name, job title, base pay, overtime pay, other pay, benefits, total pay, benefits, then the year, some nodes which has null values, agency, and then status column which has null values as well. Next up, we will use the info method to find out more about the entries in the dataset. So what this shows is, in total there are 148,654 entries in total, range with the index ranging from 0 to 148,653, and in total there are 13 columns. As we have seen above, for these rows all of these are non-null columns. That means there is data for each row in those columns, that is for ID, employee name, and job title. Thereafter there are some rows which doesn't have data. Those are null rows or null values. As you can see in the nodes and status column, there are 0 non-null values. That means all of those columns, the entire column has null values in those two rows, sorry, in those two columns. Now we will start analyzing the data. The first question is, what is the average base pay? So as we take a look at our data frame, we have the base pay here, and we have to find the average of this column. So what we will do is, we will use the mean method with that column, and we get our answer, which is $66,325. Next is, what is the highest amount of overtime pay in the data set? So let's take a look at our data frame once again. We have this overtime pay column. We have to find the highest amount, so we can use the max method with this column. And we get our answer, which is $245,131. Next up, we have to find what is the job title of Joseph Driscoll. Now remember, the question here says to use all caps, otherwise you may get an answer that doesn't match up, as there is also a lowercase Joseph Driscoll. So here what we will do is we will filter the data frame using the job title column for the person whose name has the string Joseph Driscoll. So when we check the conditional equality, we get all of these false here, but one of these must be true. Now we will pass this truth series within the data frame, and it will return only the rows where this value is true. There you go. So we have this row where the employee name is Joseph Driscoll and his job title is Captain Fire Suppression. Now to pull just the job title, we could just index it for that row. That is Captain Fire Suppression. Next up is how much does Joseph Driscoll make, including benefits. We will use the same method here as well. So we have the total pay benefits column. We will just index it for that column. So there you go. He makes a total of $270,324. Next is what is the name of the highest paid person, including benefits. So there are a couple of ways of doing this. One is we could sort the data frame using that total pay benefits column in the descending order from highest to the lowest, and then just take the head, that is the first row of the data frame, that will return our data for the employee who has the highest pay. The other method is using the max method, where we could filter the data frame, filter that column for the highest value in that column, and then we have an argmax method as well. Argmax will return the index of the highest of the max value, and we could use that index number to pull that row. I will show you all three of those methods. First up, I will show you the method to sort it in decreasing fashion, sort it by highest to lowest. We will use the sort underscore values method. Here if you check the signature, you will see we have few parameters here. We are going to use the by uh, parameter, which will be for the column name, Then ascending is true. Ascending gives it the order of lowest to highest. We want to go from the highest value to the lowest value, so we will have to uh, turn the ascending into false, and we will see others as we go ahead. The data frame is now arranged uh, in the descending manner. For the total pay benefits, we can just take the head column and it will return the row which has the highest pay benefits. And to pull the employee name, we could just index the employee name column. For the next method, we will use the max value. So here, if you see what this max returns is, it just returns the maximum value in that column. So we will filter this column just for that value, and the data frame will return just one column, or rather the data frame will return just one row, and that has our employee who has the maximum pay benefits. For the next method, we will use argmax. So as you see here, the argmax method returns the index, which is this 0, and we will pass this within the iloc method or the lock method to index the data frame based on the row. And this returns a series which is basically just the row containing the uh, all of the data of this 0 index. If you want just the name, you can index it for the employee name. That is Nathaniel Ford. Now moving on, next is what is the name of the lowest paid person including benefits? Do you notice something strange about how much he or she is paid? So let's try this by one or two different methods. This time we want the uh, lowest value in that column, and we know the parameter ascending is by default true, which means the data would be arranged from lowest to the highest, so we don't need to use that parameter as it's already true by default. Just take the head of that uh, data frame, and we have our name of the lowest paid person is Joy Lopez, and the strange thing about her is she has a total pay of negative $618. That means she owe money to the city. We'll use the second method of the min value as well. So what this will return is the min value from that column, and then this part will filter it for that min value and will take the head of that data frame. Next is what was the average, that is mean base pay of all employees per year. So let's check that year column once for to check how many years are there. We can choose the unique method to check all values. So we get an array of four values: 2011, 2012, 13 and 14. So in total there are only 4 years, and what we have to do is to find the mean base pay of all employees for each year. So here we will use the group by method to group the data frame by the year, and then use the mean method to find the average of the base pay. Group by, let's check the signature. Here we have to use a column by which the data frame is supposed to be grouped, and we will use the year column. Then axis is row by default, and you can check out the rest of the parameters as well. For now we will use just the year column. So this returns a group by data frame at this location in the memory. We cannot check this without using an arithmetic method on this. So we will select the base pay column and use mean on that column. And here we get our answer. That is, as we see, as the years increase, the base pay has also increased from 63,595 to 65,000 something to 69,000 something. But in the year 2014 it has gone down to 66,564. Next we have to check how many unique job titles there are. So just similar to this question, I will use the unique method to check how many unique values there are. So here we have an array of all of the values. We cannot count these as not all of the values are present. There are a couple of ways we could get the number of unique values. One is to use the length method on this array, which is like this, and we get our answer, which is 21,059. The second is to use the n unique method, which will directly return the length of that array, or rather how many unique values there are in that column. Which returns the same answer. Next is, what are the top 5 most common jobs? Here let's first use the value count method. Just like the unique and unique methods, what the value count does is, for a given column, it will return us the frequency of each of the unique values in that column. This tab, it will autocomplete. Now there you go. So what this has returned is a series where the index is the job title column with each of the unique values available in that index, and as the data it has returned an integer column which is arranged in a descending manner with highest occurring to lowest occurring. Now we need to find the 5 most common jobs. So that would be the top 5 columns of the data frame, or the series rather. So we can just take a head of top 5. But before that, I also want you to show the signature of the value counts and see the parameter ascending is false. That means the values would be arranged in a descending manner from highest value to the lowest value. Now let's take the head of this series, and it returns the top 5 most common jobs, which are transit operator, special nurse, registered nurse, public special aid, public works, and public officer 3, which matches to the answers given here. Next is how many job titles were represented by only one person is 2013. That is job titles with only one occurrence. So there are a couple of conditions here. One is the job titles which had only one person, and it also says it is only for the year 2013. So first we will use a filter on the data frame to sort it only for the data from the year 2013, and then we will use the value count method on the job titles column and will select only the values which has one job or one person working in that job. We'll pass this through the data frame. So here, as you can see in the year column, we only have the 2013 rows. Now to this data frame, we will use the value count method to this job title column. So for this year, it returns all of the job unique job titles with their frequency. Now we only want those which have 1 as value. So what we can do is check this for equality to 1. This will return a false and true for each of those values. It will return true only where the value is 1, and for everything else it will be false. So the simplest method to get the total sum of these rows is to use the sum method on this series. There you go. So what this does is it takes the value as 0 for all the false and 1 for true and adds everything up, which means there were in total 202 trues in that series. So the next question is how many people have the word chief in their job title? So for this, first we will check the job title column. So as you can see here in the first row, it says General Manager Metropolitan Transit Authority. So clearly the word chief is not in this row. If you look at the fifth row here at the index 4, the word chief is available, is present in the job title. So we need to figure out all if the word chief is there in which of the rows of this column, and for that what we could do is we could create a new row in the data frame and we will use the job title column to put true or false in that new column. True if the word chief is available, is present in the job title column, or false if it is not there. So I will show you. So here what I did was I took this job title column and used the apply method to apply a function to check if chief is in the job title. I used the lambda expression to create a temporary variable x, and I check for this string chief in x.lower.split. What this does is it converts these strings into lowercase and then splits it based on the white space and creates a list for that. And if the word chief is in that list, then it will return a true, otherwise it will return a false value. And as you can see here in this chief column, newly created chief column, the first four values in the first four rows are all false because the word chief is not in the job title. But for the fifth row, the word chief is in the job title, therefore it returns a value true. We could take a sum of this column as all of the false values has a value of 0 and all the trues have value 1. So it will add all the trues and return the sum, which will denote how many trues there were. And there is our answer 477. Now there's another thing here. We just checked for the word chief, but we didn't check for any punctuation marks attached to the word chief, like the exclamation mark or a comma after chief. And I know there are some words, so we will check for that as well. What we will do in this is we won't split it into a list. This word chief is already a string, and what this x.lower produces is also a string. So we'll just check for this string inside the bigger string, and if it is available there, it will return a true value. And this returns 627. So that means roughly there were 150 more chief strings in the job title which has a punctuation mark attached or some other characters attached, either just before the word chief or after the word chief. Now let's move on to our last question here. The question is there a correlation between length of the job title string and salary? So for this, first we have to find the length of the job title. For that we will create a new column and use the job title column once again to find out the length of the string in each row. So here, as you can see, we have got our new column which contains the length of the string in the job title. Now we need to check for the correlation between this title length and total pay benefits, and for that we can use the correlation method. And there we get a negative correlation between the title length and total pay benefits, but the value is very small, so there is almost no correlation. For perfect correlation the value would be 1. So that's all for this video. Thanks for watching.